So now in this video, we have an NPN bipolar junction transistor. I'm using the 2N 3904, emitter at the bottom, base in the middle, and collector on top right there. Emitter base collector, emitter base collector. So it's wired as an emitter follower. What that means is you set a voltage at the base. So trim pots are known for being able to set a voltage but not provide power. So it takes that base voltage and actually transfers it to the emitter. So a little bit of current's going to go base to emitter, but thanks to the way we wire this up, not much at all. Once a little bit is going, a lot more is going to be allowed to flow from collector to emitter. It's going to take over there. The main thing is the collector current can only build up the voltage that still allows base to emitter current to flow right there. So ultimately what it does is it sets a voltage about 0.6 volts less than the base voltage at the emitter. And sometimes you might need a 10K works well, it doesn't have to be 10K, but sometimes it helps to have a resistor going to ground to maintain that voltage, but also you have a load that is headed to ground, it will have that voltage across it. So in this case, we have a red LED with 220 ohms of resistance, and the trim pot is set to 0 volts, so it's not going to light up. Once we get to around about 2.6 volts, approximately in that range, you're going to start seeing the red LED glow a little bit. So that's the voltage across the load. We're going to have to get closer to 3 volts at the trim pot in order to set that voltage. But there you can see, I keep turning up the voltage and the LED gets brighter. Pretty straightforward. The trim pot could not power the LED like this directly because it has this is a 10K trim pot, has thousands of ohms of resistance headed to the positive supply right there. We need a relatively direct connection to the positive supply. The transistor allows a lot more current to flow through than the trim pot would by itself. So now what's really important for this circuit is understanding the voltages involved. So we're going to look at that with the multimeter here. So I can just clip this, I crimped it to the jumpers there. Our voltages are going to be in relationship to ground. And there we go. It's emitter follower. Voltages are in relationship to ground. And then for the red probe, we got up here. So now we can plug it in wherever we want. So I have the power supply set to 5 volts, a little bit above 5 volts right there, but it fell on 5 volts pretty good. We got a little resistance to the wire. So first let's look at what's across the load right there. So if the LED is glowing a little bit, I did dim the lamp. You know, you got somewhere about 2 volts. It does conduct a little bit lower. I think about 1.5 when current is very low, like you see here, and then the rest of the voltage goes across the resistor. So we're at the emitter, goes across the resistor and the LED down there, and directly across this resistor to ground. So yeah, we got about 2 volts there now, and so LED is lit a little bit. Remember, not all that voltage is across the LED. We can look at how much is across the resistor. It's a 220 ohm resistor, and then you know, 0.2 volts. See how much current is flowing. But in any case, let's get back to this. So 2 volts across the LED and the resistor. Now we'll go up one more spot to the base of the transistor. So that's the voltage of the trim pot right there. So as long as you can, you know, reliably, you know, you can't see the voltage of the trim pot unless you're measuring it like we are right now. But if you have a way to set the voltage of the trim pot, if you want 3 volts across the load, of course, we won't get 5 volts across the load. We are at the limits of the power supply. So when it comes to the trim pot, the base to emitter is always going to drop about 0.6 volts. So it'll probably be about 4.3, maybe 4.4 volts across the load right there. You can see in the middle. Something to be aware of. You're not going to get all the way 5 volts across the load in this particular setup. But yeah, we can set, let's say we want 3 volts across the load. So since we're going to the base of an NPN bipolar junction transistor, set it about 0.6 volts higher than what we want. So 3.6 volts. And now across the load right there. We got, you know, basically 3 volts right there. Not going to be spot on. It's going to be in the range, you know, but that's perfectly fine. But in any case, this illustrates how you can use a NPN bipolar junction transistor as it's not quite a voltage follower because you don't get the voltage in, the same voltage out. It's about 0.6 volts less. So it's at the emitter, headed to ground, so it's called an emitter follower. The load follows the emitter, and therefore it's about 0.6 volts less than what we got there. I had some connection problems, that's why the LED kind of flickered right there. So, in any case, make sure you turn off the meter when you're done. Hopefully it automatically shuts off after a period of time, but probably better. Just shut it off anyways and remove your connections. So that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out links down below. They all help out a lot. I'll see you in the next video.